Hello, good evening. So, uh, today is day 2 of machine learning, and today we will be discussing about probabilistic prediction. Probabilistic prediction. Okay, so yeah, what is this and why we need probabilistic prediction is to handle ambiguous cases. Ambiguous cases. So, what actually happens? Suppose there is a class 1 and there is class 2, right? And we have some data, this data point. Now this data points must have some features, right? X1, X2, and from this feature it is not clear whether this data point belongs to class 1 or class 2. So uh, maybe some of the features like X1 is uh, the feature of X1 is much more uh, compared and related to class 1, and feature of X2 is much more saying that data X is belonging to class 2, right? So what to choose and how to proceed? For this, what we will do, we will find out probability distribution for y given vector x and data point. Okay, so now suppose if there are two classes only. Okay, so what we need to find? We need to find p y equals to 1 given vector x and data, as well as p y equals to 0 given vector x and data set, right? In fact, we don't need to find this two. Can you say why? Yeah, you're guessing right. Because if there are only two classes, then either it will be, so what I am saying, if the classes are only two, then C must belongs to either class 0 or class 1. So if we sum all these two probabilities, this must result to 1 only. So we don't need to find both of them. If only we can find one, then we can find the other by subtracting from 1, right? But this is true only for class equals to 2. If class is 3, then we need to find 3 probabilities. So okay, so after finding this probability and this probability, what will be our state? Suppose, for example, the probability uh, of y to be class 1 is 0.6 and this is 0.4, right? So how to proceed? Yeah, one with highest probability will be assigned. So uh, our data set data point x will be assigned to class 1. So mathematically we can write that as y cap predicted y equals to f hat, which is equals to arg max. Okay, 1 for all c p y equals to c x d. Okay, so for whichever class the probability is maximum, we will assign, we will select that c and will assign to y hat. Okay, now let's move to next topic, that is regression. Okay, see, I am just introducing these topics and I will be going to more in depth in later classes. Okay, this is just for introduction so that you have a basic idea what's actually happening. So in regression, what actually happens, that our input xi belongs to set of real numbers, right? And it gives output y, which also belongs to set of real numbers. So the response variable is continuous here. Okay. Mm, Now what happens in unsupervised learning? Supervised learning, that we see in supervised learning, what was happening, that we are guessing the probability distribution of y given vector x and data set. But in unsupervised learning, we don't have this level, right? So we will be only taking the vector uh, input vector x given all the parameters, and we will try to find out the density. Okay, so it's more or less like density estimation. Okay, density estimation. So our first task is to estimate the distribution over the number of clusters. So what I mean by that is that suppose there are some points, okay, and since it is not leveled, see, if the data is leveled, then we have only a limited information, right? So about the feature which we are trying to predict. But if we leave everything to the model to guess the unique features, okay, so therefore it is also known as knowledge discovery, right? So then the model itself will try to find out the similarities between the data set. So it may say that the model may guess that this can be a one cluster and this can be a cluster. Okay, so and within this cluster there may be, this can be a cluster and this can be a cluster. So it's all depend upon the number of clusters which we are choosing, which we are uh, putting as variable and letting the model to uh, to discover which points are similar, which points are not similar. Okay, so what actually we are doing here is that for this unsupervised learning, our first task will be to estimate the distribution over the number of clusters, right? So we will be trying to find out the k value based on the data set, right? So yeah, and what will be our second step? To reduce reduce the dimension. Okay, so if we can reduce the dimension uh, of these points, then uh, it will be much more easier for us to find out, to compute, right? Because we all know. Okay, so how can we reduce the dimension using PCA? Okay, principal component analysis. And if we don't reduce the dimension, then okay, there you may suffer with extra computation. Okay, so the curse of it is also known by curse of dimensional. So I will be touching that point a little later, but let me write curse of dimension. Dimension. Okay, so yeah, I will be sharing this point later. Just now, I'm just giving some basic ideas. Okay, there are one more term like parametric and non-parametric models. Okay, so what is this? So parametric models are of form P, this is P, right? P, Y given X bar, or we can also say P, X bar. So these are probabilistic model. Okay, so we say a model is uh, parametric if the parameters of the model are fixed. Okay, but if the parameter of the model keeps on growing with the amount of training data, then we will say it is non-parametric. So if the model is parametric, then it definitely will be little faster. Okay, but if it is not parametric, then although it is flexible, but it will be little slower. So let me give you one example. KNN. Okay, you all may have some basic idea about KNN. This is known as K nearest neighbor. Okay, so if there are some points and we want to check this, there is another point and we want to know which cluster it belongs. or which class it belongs based on the nearest neighbors, that is the points um, around it. So we can do this by using KNN. Okay, so KNN is given by x, d and k, which is equal to 1 by k, which is equals to 1 by k summation of I yi equals to c. Okay, where this is not pi, this is I. Okay, I. So this is also known by indicator function. So if this condition is true, then this function will return 1, and if this function, if true, if this function is false, then this entire indicator function will return 0. Okay, so yeah, and this summation is running from I for all I belongs to nk d, right? So what is I? I is the index uh, of the points of the input. Okay, so if uh, a vector x I, let me explain another way. So yeah, suppose there are some points, right? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, so this numbering is like I. Okay, and this means for this test data point, whatever number, whatever points uh, which are the at minimum distance, the top k points which are at minimum distance will be selected in this I. So suppose if there is this test point and k is 3, then this 3 point will be selected. Then I will be 2, 4 and 5, right? Okay, so give me give you one more example. Same example I am expanding. Okay, so for p y equals to 0, x d k will be what? 1 by k, that is 1 by 3. Okay, summation for all i's in n. So there are 3 i's. Suppose this two are green, but this is black. Suppose this is black, this is black, this is black. Okay, so okay, for point, this one is black, rest are green. Okay, so point for, see the formula, yi is equals to, I'm giving asking for y equals to 0, so c is 0, right? So yi equals to 0, 0 means green. So yeah, point 2 I2 y2 equals to class 0, y4 equals to class 1, and y5 equals to class 0 again, right? So this is true, this is true, this is false. So here the summation will be 1 plus 0 plus 1, right? So here the probability is 2 by 3. Similarly, if you do for py equals to 1, it will be 1/3 0 plus 1 plus 0, which is equals to 1/3. So argmax will be this one, and y equals to 0 will be selected. So we can say that this point is green based on k equals to 3. Okay. So let's move next topic, linear regression. Okay. So what happens in linear regression is that there are some points, right? And we are trying to fit this point using some curve. Okay. And by linear we mean the input depends linearly on output, right? So yx equals to wt x plus e. This will be the formula for linear regression, right? W are weight, x is the point, and e is error. What is this error? Okay, this is x, this is yx, and this line is nothing but y hat x, and this one, this distance is error e. Okay. The feature of e is that we normally take it as a residual error, and it is represented as Gaussian distribution with mean equals to mu, and uh, with standard deviation equals to sigma. Okay. So yeah, one more thing, we can definitely represent a non-linear uh, way by just formatting the formula. The new formula will be ywt phi x, okay, plus error. What is this phi x? This is a function, okay, non-linear function of vector x, where the feature can be x can be uh, x x bar square x bar q dot dot dot. So it is this function, right? Okay, let's meet in next video. Bye.